At this workshop, we will introduce a new software called R-Instat. We'll briefly describe what it is and outline some of the ways it can be used by climate services across Africa. R-Instat began in 2015. We identified a need in Africa and beyond for a new statistics package that would be powerful, easy to use, and freely distributed. In addition, it was important that the development of the software be largely within Africa. Initial funds were raised through a crowdsourcing initiative, and further funds in 2016 enabled a dedicated climatic menu to be added to the software. The original Instat was first developed in the 1980s. It provides a very simple statistics package with a special climatic menu. In 2017, this remains in use at many Met services in Africa and beyond because of this special climatic menu, which, as you can see here, includes tailored products such as start of the rains, length of the rainy season, and the risk of dry spells. Instat is soon to be replaced by R-Instat. R is a very powerful, popular, and free statistical system. In addition to the core system, users have contributed more than 5,000 packages to enhance its capabilities in many fields, including the analysis of climatic data. CM-SAF, which is used in this workshop, is one such package. RStudio, shown here, provides a powerful and useful environment to run R directly. R-Instat provides a menu-driven front end to R. It is designed to make R really easy to use. In R-Instat, all analyses are done by R, and the results are then transferred back to the front end. The resulting software looks a little like the original Instat, though none of the original code remains. It is a different package and much more powerful than its predecessor. Like the original Instat, it is a general statistics package together with a special menu to facilitate the analysis of climatic data. R-Instat will be used alongside the CM-SAF toolbox in this workshop. The CM-SAF toolbox is also based on R and will be used through RStudio. As you can see from this slide, the two softwares complement each other well. The top part of this slide outlines the roles of these two tools in more detail. R-Instat is still only a beta release, but it's already usable for the tasks shown here. Starting with station data, we can examine these in detail, and they can then be compared with satellite information from the same sites. The overall aim is for countries using both station and satellite-based measurements to be able to provide information to users for anywhere in their country, whether or not there's a station close by. Please take a moment to look at in more detail the roles and workflows of CM-SAF R Toolbox and of R-Instat. The workshop does not have much dedicated time for learning R-Instat. However, the software has been specially designed to be easy to use and feel familiar to anyone who's previously used a statistics package, such as the original Instat or SPSS, as well as for those people who have experience analyzing data using a spreadsheet. Participants will therefore be able to move quickly into using the package for their data analysis. R-Instat has been designed to feel like a spreadsheet so that people can enjoy the familiarity of a well-known environment. However, it also has a few differences which we think make it simpler and more effective to use. Let's look at some of these similarities, shown with a tick, and differences marked by a cross. Like in a spreadsheet, the data are in columns. For example, one column may contain the rainfall, while another indicates which month the data come from. The first row in R-Instat contains the name of each column. Then the data start in row 1, We prefer that to a spreadsheet where the data usually start in row 2. A big difference, as you can see in the figure, is that like most statistics packages, RInStat displays its results in a separate output window. The RInStat menus correspond to the usual stages in an analysis. The File menu is used first and is to access and import data. Then most sets of data need some organizing before they're ready for analysis. This is the role of the Prepare menu. Next, the Describe and Model menus are used for the analysis. The Climatic menu contains some facilities from each of these previous menus. This makes particular climatic analyses even easier, as we'll see during this workshop. Here is the first of 3 examples. The daily data were available, and a Prepare dialog was used to produce annual rainfall totals ready for analysis. The Describe menu offers options for many types of graph, as well as tables. The example shows box plots for the daily maximum temperatures of 2 stations in Ghana. With daily data, a useful graph on the Climatic menu shows an inventory of the available data. Missing data is shown in red, with a time on the x-axis. The bottom row in each part of the graph shows that rainfall data were available from the 1940s, with very few missing values. The other parts of the graph show temperatures and other elements are available at each of these 2 stations from about 1960 onwards. In this final slide, we show what we plan to start with at the beginning of the face-to-face part of the workshop. You should be able to read your station data from various formats. There's a special dialog in the Climatic menu to read net CDF files containing satellite data. Then away you go.